All right, we were just talking about covalent bonding, or I'm sorry, ionic bonding, and we had said in some cases, depending on the atomic number and the number of electrons in the outer electron shell, in some cases, an atom has just one outer electron, and somebody else has 7, but we'd said the rule of 8s is trying to get to 8 in each of those electron shells. So we had said that you can produce a cation and an anion, and everyone's happy, and those two ions stick together. But that doesn't work for most chemicals because they have a different number of outer electron shell electrons. And so if we look at oxygen, I've got hydrogen written up here, drawn up here, and I have oxygen drawn up here. And you can see, if you just remember, we had said hydrogen has a single proton, so a single electron, and it only needs one. It needs one to be filled because the inner shell only holds 2 electrons. All the other ones that we're worried about hold 8. But anyway, so the hydrogen has just a single electron in its outer shell. Now the oxygen, on the other hand, it has 8 protons. And so if we say, okay, 2 inner electrons, and then that leaves 6 outer electrons, it needs 2. See, so what it does is it does this other kind of chemical bonding, and it's a kind of chemical bonding called covalent bonding. And what happens, it ends up that they don't have to just own the electron, they can actually share it with the partner. So in covalent bonding, what happens is the 2 atoms that are involved share pairs of electrons. And this fulfills the rule of 8. And what did we say that means? That means that they gain stability. It fills out their desires. They gain stability. Snap out of it, Steve. Anyway, it gains stability. So if we think about this water, or I'm giving it away. If we think about this oxygen and hydrogen scenario, what can happen, and what does happen, is you have 2 hydrogens that each one is going to share a pair of electrons with the oxygen. And so we had said this is the shape that a water molecule takes. And in a water molecule, the oxygen shares pairs of electrons with 2 different hydrogen atoms. Each hydrogen atom only has 1, but it needs 1. So this guy, they're sharing this pair here, and the electrons, they can be down here or they can be up here. It's shared between this atom and this atom. Now, we said that only gets it to 7, so you got another one. It's another hydrogen that is sharing up its electron with the oxygen, so they share the pairs of electrons, and those 2 electrons can either be down here or they can be up there. And this is covalent bonding. So covalent bonding involves sharing of pairs of electrons. Now, if I was to, so I'm going to go on and stop there. I'll stop there and we'll talk a little bit more about some of the minutiae, the details of covalent bonding. There's 2 different kinds of covalent bonds. Here we go.